Welcome back to Talk Tensors. You know, we love to dig into machine learning research, and today we have a fascinating paper.
Oh yeah, this one's called,
OCMDP, Observation Constrained Markov Decision Process.
catchy title.
Right. And it really caught our eye because it challenges this idea that in machine learning, more data is always better.
Yeah, that's a common assumption, but
Well-
sometimes it's just not true.
Exactly.
I think in this paper, the authors argue
Yeah.
that in a lot of real-world situations, just gathering information,
Yeah.
it can be expensive, take a bunch of time, or even be risky.
Yeah, totally. And they propose this new framework.
Called OCMDP.
Yeah. And it forces the AI to be more selective about the data it uses.
Makes you think, huh?
It does. It really does.
Like imagine
Like a doctor,
you're a doctor and you're trying to figure out what's wrong with a patient.
right?
You could run every single test imaginable.
Huh.
But-
It'd be a nightmare.
Be expensive, it'd take forever, and probably stress the patient out.
Oh, yeah, for sure.
OCMDP is all about figuring out like which tests are absolutely essential.
To make the right call.
Yeah, and which ones you can probably skip.
I love that analogy.
It really gets to the heart of the paper.
Yeah.
Sometimes knowing less can actually be better.
Especially when those observations are so expensive.
Exactly.
So how does OCMDP actually work? It sounds super complicated.
Well, it's based on something called a Markov Decision Process.
Okay. I've heard that.
You know, it's a mathematical framework for making decisions when things are uncertain.
Right.
But in a traditional MDP, we assume that the agent knows everything about the environment.
Okay, so perfect information.
Yeah, exactly. But OCMDP changes things up
How so?
by adding observation actions.
Observation actions.
Mhm.
So the AI has to decide what to do and what to look at.
Exactly.
Wow, that adds a whole other level.
Oh, yeah, it's really complex.
Because now the AI has to balance
The potential benefits of getting more information.
with the cost of actually doing that.
Right. So it's way harder to find the best strategy.
Okay, that makes sense. So how do the authors tackle that?
They have this clever solution.
Okay.
They break the problem down into two policies.
Two.
Yeah, one for control and one for observation.
So they're training the AI to learn two different things.
Basically, yeah, it learns when and what to observe,
Okay.
and then what action to take based on what it knows.
So it's like separating the seeing from the doing.
Exactly. And that makes it much easier for the AI to learn.
Mm.
What's even cooler is that the AI doesn't need to know everything about the environment beforehand.
So it can adapt
Yeah, to all sorts of situations.
without being specifically programmed.
Right. Pretty neat, huh?
Really neat. So OCMDP sounds great in theory, but how does it actually perform?
Well, they tested it in two simulated environments.
Oh, okay.
The first one is called the diagnostic chain.
Interesting name.
Yeah, it's a simplified model of a patient moving through different health states.
Okay.
And the AI is like the doctor. It has to decide whether to observe the effects of a treatment or move on to a different treatment.
And of course, it has to consider the cost of each observation.
Right. It's a classic cost-benefit dilemma.
Do you spend the resources to get more information or take a leap of faith and hope for the best?
That's exactly the kind of trade-off that OCMDP is meant to handle.
So what about this second environment?
That one's called heart pull, and it's more realistic.
Okay.
It simulates a healthcare scenario, and the AI has to balance keeping a patient healthy,
Right.
maximizing productivity.
Ooh, so it's like work-life balance, but for an AI doctor.
You got it.
I like that.
Yeah.
So in this environment, the observations would be things like,
Checking vital signs.
yeah, running tests,
Uh-huh.
which all cost time and resources.
But they could also improve the patient's health.
Right. So the AI has to learn to weigh those costs and benefits.
You make the best decisions.
Did it work?
The results are really impressive.
Oh, yeah.
In both environments, OCMDP significantly reduced those observation costs.
Wow. And it didn't sacrifice performance.
Nope. It actually did even better than some other methods.
Like how much better are we talking?
Well, in the diagnostic chain environment, it cut observation costs by 50%.
50.
That means it achieved the same level of performance, but using half as many observations.
That's incredible. What about heart pull?
Even better.
Really?
Yeah, it was about 75% better than the next best algorithm.
Wow, that really shows the potential.
It does.
Yeah.
For making decisions under uncertainty.
This OCMDP framework is pretty powerful.
It is.
But what does it all actually mean for us in the real world?
That's a great question.
Yeah.
And we'll dive into some real-world applications and potential future directions.
Okay, sounds good.
After a quick break.
All right, we'll be right back. Welcome back to Talk Tensors. So before we went to break, we were talking about the observation-constrained Markov decision process.
OCMDP.
Yeah, OCMDP. and its performance in those simulated healthcare environments.
Uh-huh.
Now, I kind of want to shift gears a bit and talk about like the bigger picture.
The broader implications.
Yeah, where could OCMDP really make a difference?
Well, healthcare is a pretty obvious one.
Yeah, we talked about that.
Like with medical diagnoses, you often have all these tests and procedures.
Yeah, some of them can be really expensive
Oh, yeah, and time-consuming.
and risky for the patient.
Right.
So an OCMDP system could help doctors decide which tests are actually necessary
And which ones they can skip.
to make healthcare more efficient and cost-effective.
Exactly.
It could really change the way we approach diagnosis and treatment.
For sure. And I think OCMDP could also be useful in other areas where information gathering is expensive or takes a lot of time,
Like what?
like environmental monitoring.
Hmm.
Scientists use sensors to collect data on things like air quality, water pollution, wildlife populations.
Right.
But those sensors can be expensive to operate and maintain.
So an OCMDP system could help them be more strategic.
Exactly. They could deploy the sensors in a way that maximizes data collection, but minimizes the cost.
And it could even adapt to changes in the environment.
Right, and prioritize the most important observations.
That's really cool.
I think so. And another area where OCMDP could be huge is in robotics.
Oh, yeah.
Like, imagine a search and rescue robot in a disaster zone.
Okay.
It needs information to find survivors and avoid dangers, but it also has limited battery life and processing power.
Right. So we can't just gather information endlessly.
Exactly. An OCMDP system could help it decide which sensors to use and when.
To be as efficient and effective as possible.
Right. It's all about balancing the need for information with the limitations of the real world.
And OCMDP does that really well.
It does.
This makes me think about how we gather information in our own lives.
Yeah.
We're constantly bombarded with data from our phones, our computers everywhere.
Information overload.
It's overwhelming. OCMDP offers a different way of thinking.
To be more selective.
Yeah, to focus on what's really important.
And ignore all the noise.
Like Marie Kondo for our minds.
Ah, I love that.
Does this information spark joy?
Right. Or in this case, does it help us make a better decision?
Exactly.
But seriously, I think OCMDP has some big implications for the future of AI.
In what way?
As AI systems become more advanced and integrated into our lives, they need to be able to make decisions with limited information.
Yeah, they can't always have perfect information.
Right. They need to be able to handle the messiness of the real world.
And OCMDP provides a framework for that.
It does. It helps build AI systems that are more robust and adaptable.
So more intelligent.
Exactly. This paper is pushing the boundaries of what's possible in machine learning.
I'm excited to see where this research leads.
Me too.
Speaking of the future, I want to get your thoughts on some potential avenues for future research.
Okay.
This is our novel notions segment where we like to speculate about the possibilities.
That's fun.
So one area I'm curious about is extending OCMDP to multi-agent systems.
Multi-agent OCMDP.
Yeah, so instead of one AI agent deciding what to observe, you have a whole team of agents working together.
Coordinating their observations and actions.
Exactly. Like those robots we talked about.
Exploring a dangerous environment.
Yeah, each robot has its own sensors, but they can share information.
To get a better understanding of their surroundings.
And an OCMDP framework could help them decide which observations are most valuable for the whole team.
Right, to avoid redundancy and maximize efficiency.
They could work together to gather the information they need while saving resources.
Exactly.
Or imagine self-driving cars in a city.
They could share data about traffic road hazards, weather patterns.
To make transportation safer and more efficient.
It's fascinating to think about how OCMDP could be applied to systems with multiple decision makers.
It could lead to breakthroughs in robotics, transportation, healthcare even.
I agree. And here's another thought.
Okay.
What if we made those observation costs dynamic?
Dynamic.
Yeah, so they change based on the situation.
Like in medical diagnosis.
Right. The cost of a test could depend on the availability of equipment or the expertise of the medical staff.
So the AI would have to adjust its strategy.
Exactly. It would be like a risk-sensitive OCMDP.
Where the cost of missing important information is higher in certain situations.
Right. It could lead to systems that are more adaptable and responsive.
Systems that can change their information gathering strategies on the fly.
Yes, the idea.
These are some really amazing ideas.
It's all speculation, of course.
Sure, but it shows the potential of OCMDP to change the way we think about information and decision making.
I agree. It's been a really interesting discussion.
It has. We tend to think that more information is always better, But this paper challenges that assumption.
Sometimes knowing less can lead to smarter decisions.
And that's a powerful message. Welcome back to Talk Tensors. We were just talking about those multi-agent OCMDP systems.
Oh yeah, where the agents work together to figure out what information is most important.
Exactly. We talked about robots and self-driving cars, but what about something like financial markets?
Oh wow, that's interesting. You could have a bunch of AI agents each specializing in a different part of the market.
Yeah, and they could share information about trends, economic indicators, all sorts of stuff.
To make better investment decisions.
Right. And with that OCMDP framework, they could avoid getting overwhelmed by all the data.
And focus on what really matters for making money.
It could make the financial system more efficient and stable.
For sure.
It's amazing to think about the possibilities. But let's get back to the paper itself.
Okay.
Was there anything else about this research that you found interesting? Any strengths or weaknesses we haven't talked about?
You know, one thing that really impressed me was how thoroughly they tested their approach.
Yeah, they used two very different simulation environments.
Which shows that OCMDP is pretty flexible.
And they compared it to other methods.
Right. And it consistently outperformed those traditional reinforcement learning algorithms.
The ones that don't consider the cost of information.
Exactly. So they didn't just come up with a new theory, they actually showed that it works.
That's really important.
It is.
As for weaknesses, I think one area for future research could be looking at how to handle more complex observation models.
Oh, yeah. The current framework assumes that the cost of observation is fixed and we know it in advance.
And in the real world, that's not always the case.
Right. Like in medical diagnosis, the cost of a test could depend on a lot of things.
Like whether the equipment is available or the expertise of the staff.
Exactly. So if they could develop an OCMDP that can handle those dynamic costs, that would be a big step forward.
It would make it even more practical.
For sure.
Sounds like there's still a lot of work to be done.
Oh, yeah. But this paper lays a really solid foundation.
It does. This whole deep dive has been really eye-opening.
Oh, it has.
It's so easy to get caught up in the idea that more information is always better.
But sometimes knowing less can lead to smarter decisions.
That's a great takeaway. So on that note, I want to thank you for joining us on this deep dive into OCMDP.
It's been fun.
And we encourage all our listeners to check out the paper themselves.
You can find a link in the show notes.
Until next time, keep those neurons firing.